Hello, my name is Dr Sotiria Fotopoulou and I'm an astrophysicist at the University of Bristol. Today we are going to discuss about one of the most important telescopes in the world, the Hubble Space Telescope. Let's start with some key facts. The Hubble Space Telescope is a joint effort between NASA and ESA. It was launched in April 1990. The primary mirror is 2.4 meters, which is the average height of two 7-year-olds. The mirror, along with all of the instruments, fits into the telescope, which has a size similar to a double-decker bus, just over 13 meters long and weighs more than 12 tons. Hubble uses the sun as its energy source. The space team at Filton took part in developing the first solar arrays. Hubble creates 18 gigabytes of data per week, which is equivalent to taking more than 5,000 photos with a phone. And of course, to keep this impressive telescope operating in good order, there is a dedicated team of scientists and engineers in space and on Earth. But who was Hubble? The Space Telescope is named after Edwin Hubble, an American astronomer. Hubble was the first to provide evidence that there are many more galaxies in the cosmos outside of our own Milky Way. He created the first classification of galaxies based on their morphology. He ordered the galaxies from smooth, rounded ellipticals on one side to galaxies with prominent spiral arms on the other side. This classification scheme is used still today. He also showed that all galaxies are moving away from each other. Imagine that you draw two dots on a balloon and then you inflate it. The dots will move away from each other. In a similar way, galaxies in the universe are also moving away from each other because the universe is expanding. Now let's go back to the telescope. How does the Hubble Space Telescope work? Hubble is what we call a Cassegrain design. The light enters the telescope and gets reflected first on the primary mirror. The primary mirror gathers the light on the smaller secondary mirror. Finally, the light passes through a hole in the center of the primary mirror and it is focused on the scientific instruments. Hubble has been operating for more than 30 years. Let's have a brief look in its history. Already in 1946, astronomers discussed the possibility of having telescopes in space. The National Aeronautics and Space Administration, NASA, and the European Space Agency, ESA, were founded in 1958 and 1975 respectively. In 1977, the Large Space Telescope project was approved. However, the tragic loss of the Challenger space shuttle delayed Hubble's launch until it was made sure that all astronauts would be safe for any future missions. Hubble was launched in 1990, and since then it has provided a number of groundbreaking discoveries. In 1994, the existence of supermassive black holes was confirmed. By 1996, Hubble had taken already 100,000 images. By 1998, there have been enough evidence to show that not only the universe is expanding, but also that the expansion is accelerating. In 2001, Hubble detected signatures of atmosphere in a planet outside our solar system, also called an exoplanet. In 2005, Hubble observations showed that Pluto has 2 small moons. By 2008, Hubble had completed 100,000 orbits around the Earth. In 2016, Hubble broke the record of the farthest galaxy ever recorded. And finally, in 2019, Hubble observations showed evidence of water vapor in an exoplanet that has the right conditions to host life. However, the life of Hubble has not been a smooth ride. Very soon after the launch, it was clear that Hubble suffered from astigmatism. Thankfully, Hubble was designed from the very beginning to have repairs and upgrades. 5 servicing missions took place between 1993 and 2009. These missions fixed and upgraded Hubble and installed new instruments. You can see on the top right-hand side 3 images of the same galaxy. The first in 1990, one of the first images Hubble ever took. The second in 1993, just after the servicing mission to fix the astigmatism. It was like putting glasses on the telescope. The final in 2009, just after the final camera upgrade 16 years later, which also shows the improvement in technology. In the bottom row, you have 2 pictures of the same part of the sky. The left-hand side is taken in the optical, where we mostly see dust and gas. The right-hand side is in the infrared. The infrared emission is not visible to the human eye. However, it has a great advantage that it passes through dust without much trouble, unlike the optical emission. So now in this picture, we can see all of the background stars we couldn't see in the optical. Now that we know how Hubble works and a bit of its history, let's take a tour of some of its most beautiful observations. First, a brief stop at the solar system. But how big is the solar system? For example, Saturn is 1.5 billion kilometers away from the Earth. This is equivalent of going around the Earth 37,500 times. Hubble has taken exquisite images of the largest planets in the solar system, seeing the rings of Saturn and the storms in Jupiter. Unfortunately, the capabilities of Hubble do not allow to study in detail smaller planets like Mars or planets further away such as Neptune. However, NASA and ESA have dedicated missions to study our solar system in detail. Moving outside our solar system, the first star we would encounter is Proxima Centauri. This star is 40,000 billion kilometers away, or equivalently 4.25 light years. Stars are born in dense clouds of dust, like the one you see on the top. Gravity will make particles of dust collide and compress until the material will be dense enough and the pressure high enough to create nuclear reactions. This is the source of energy of stars. Stars are often created in star clusters, formed from the same initial cloud of dust and gas. The stars that have small mass will live very long lives. When they will exhaust their fuel, they will become white dwarfs inside a planetary nebula. On the other hand, massive stars will live short lives and will end their lives with a big explosion, a supernova. Moving even farther away, we greet our first neighboring galaxy, Andromeda. Andromeda is too large to fit in a single Hubble image. The image you see here is a combination from ground-based telescopes, and only the highlighted part has been imaged by Hubble. Even though Andromeda is our closest neighbor, it is 23 quintillion kilometers away, or 2.5 million light-years. This means that we see Andromeda as it was 2.5 million years ago. Galaxies are a collection of stars, dust, and gas. They have many shapes, as we have seen in the classification sequence introduced by Hubble. Elliptical galaxies are smooth and they do not rotate. Spiral galaxies have spiral arms and they rotate. Some galaxies don't fall in either of the two categories and they are called irregular galaxies. These are the remnants of interactions between galaxies. Galaxies also create clusters through gravitational attraction. We can find from 100 to 1,000 galaxies inside the cluster. A galaxy cluster will have a typical size of about 3 million light-years. Zooming out even more for one final time, Hubble observed a blank spot on the sky for 10 days. What Hubble found is that there are no empty areas on the sky. Every bright spot you see in the image is a galaxy. The smaller the galaxies, typically the farther away they are. This brings us to the end for today. However, it is not the end for space telescopes. Hubble will continue to observe the universe for many more years to come. Soon, Euclid and JWST will join Hubble in observing the universe with the same exquisite performance, but in the infrared wavelengths. That is all for today. I hope you have learned a little bit more about the Hubble Space Telescope.